Okay, in this screencast we're going to look at tree diagrams, which are an excellent way of displaying the sample space of an event and their probabilities. So we're going to have a look at a couple of examples, but for your notes, just maybe pause the screen and get the example down, and then we'll sort of talk it through. But as I say in my opening statement here, tree diagrams are a great way of displaying sample space. Remember what sample space is: all the outcomes, all the possibilities, and the probabilities of each of the branches in the case of a tree diagram. So let's have a look at this example. Example 1, boxes A and B contain 4 marbles each. Box A contains 2 red and 2 green, and box B contains 1 red and 3 green. A box is chosen at random, and then a single counter or marble is selected. Marble. Draw a tree diagram representing the possible outcomes and their probabilities. So first thing that happens is that a box is chosen at random. So this is how we do it. We have a starting point. We sort of go like this. Okay, from a starting point we say, right, there's 2 possible outcomes here, box A and box B, and what we do is we just put an A and a B, so the outcome at the end of the branch. Okay, now there's only 2 boxes and it's chosen at random, so what we do along the branches, these are the branches here, is we write down the probabilities of that actually happening. So it's a half, isn't it? Half each if there's a equal chance of obviously choosing box A and box B. And then we go, right, so after that, now we've got some more options. So once we've chosen, say, box A, what are my possible outcomes now? There's red and green marbles. So I've got 2 more branches here, which are red and green. And the probabilities of each, there's 2 red and 2 green. So again, 1/2, 1/2. And then we go down to box B, and what would happen off box B? What's in box B? We've got 1 red and 3 green. So again, the probabilities, sorry, the outcomes are red, green, but the probabilities in this case will be different. Red is only 1 out of 4, and green is 3 out of 4. Okay, so what we've got here now is our sample space. Now, sample space can be written out as such. This is box A red ball. This is box A green ball. So if we follow the branches along, we arrive at an outcome. So this one here is AR, box A red ball. This one here is AG, box A green ball. This route here, BR, is box B red ball, and this one here is box B green ball. So they're our possible outcomes. Now, what are the probabilities of each of them? Well, in order to calculate the probabilities of each, we go, and if this is the probability of AR, then what we do is we multiply along the branches. So it's 1/2 times 1/2, 1/2 times 1/2, so 1/4 there. Now when I've done all these, because this is my entire sample space, I should get all these summing to 1. Let's check it out. 1/2 times 1/2 again. 1/2 by 1/2, which is 1/4. Okay, we don't always need to work out the probabilities of every single outcome. What we do is go down and answer these questions here. But I'm just, for this first one, going to demonstrate what the outcome is. So now we're down here, B followed by R, which is 1/2 times 1/4, which is 1/8. And the probability of a box B followed by a green ball is 1/2 by 3/4, which is 3/8. Okay, now if we add all these up, we get 1/4 plus 1/4, which is what's that, 1/2, plus 1/8, which is now 5/8, plus 3/8, which equals 1. So all these probabilities here should sum to 1. And now we've got our sample space, and we've got the probabilities of each of those individual events occurring. So let's go down. What's the probability of selecting box B and a red marble? Box B and a red marble, there it is there, 1/8. Alright, so we follow it along BR. What is the probability of selecting a red marble? So a red marble, well, what are the outcomes that work for this? Well, there's a red marble there, and there's a red marble there. So in this case, there's two routes that work, the AR and the BR. So what we do is 1/4 and 1/8. They both work for the question, so we add them together. 1/4 plus 1/8. This is 2/8 and 1/8, so that's 3/8. So we add those two together. So we multiply along the branches, and if there's more than one outcome that satisfies the requirements of a particular question, we add those up. Okay, let's have a look at example 2. A bag contains 5 blue and 3 white marbles, and 2 marbles are selected without replacement. So let's get the trusty bag out here. We've got 5 blue and 3 white. 5 blue, 1, 2, 3, 4, 5, and 3 white. It's pretty hard to get a white marble drawn on here, so we'll call it, yeah, we'll get 3 white. We might just change that to 3 green, shall we? Anyway, you get the idea. 3 white marbles. I wonder if on my colour wheel I can do something pretty clear. 1, 2, 3. Invisible marbles, there you go. So we've got 5 blue and 3 white. 2 are selected without replacement. Okay, so let's get our tree diagram going. So from the outset, what are our options? So what we're looking at here is 2 marbles are selected. So we want selection 1 will be, this will be selection 1. And then the second branch, so the selection 1 could be a blue or a white. Right, they're my possibilities, aren't they? There's only 2 colours in the bag. And then selection 2 will represent our second branch off. So selection 2 here, and again blue, white, blue, white. So what we're accounting for here is that if the first selection is blue, what's the probabilities now? And they're all going to change because of the balls are not being put in the bag. So if you like, this one here is actually the probability of white, not white, probability of blue given white, just to bring in some conditional probability that we looked at before. So that would be that branch there. Okay, let's work out the probabilities. We need to put the probabilities on along all the branches. So selection 1, blue, white. So we've got 5 blue and 3 white. So we've got 8 marbles, 5 of them are blue. So the probability that they're blue, the first marble selected is blue is 5/8. I've just got an idea. How about you pause it now and go and fill in these branches, and then I'll see you in 30 seconds and we'll compare answers. Pause now. So we go now to white, which is 3/8. Remember that plus that's got to equal 1. Now selection 2, the ball is without replacement. It's not being put back. So we've taken a blue ball out. We've only got 4 left. So we've got 7 marbles. 4 of them are blue, and 3 of them are white. Now if the white came out first, I've only got 2 white. I've still got 5 blue. So 5/7 and 2/7. So we could work out. This is my blue, 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 white. But this time, let's just target what we're being asked to find. Find the probability of selecting a blue marble followed by a white marble. So that blue marble followed by a white marble, that's that one there. That's the probability of a blue followed by a white is equal to, what do? Again, pause and do the question. 5/8 times 3/7, which is 15/56. 15/56, so that's my probability for part A. See if you can do part B. Again, pause the video, hit pause, and then come back. 2 blue marbles. What's the probability of selecting 2 blue marbles? There's only one outcome that works for that, and that's that one there. So the probability of a blue followed by a blue equals 5/8 times 4/7, which is 20/56, which becomes 10/, that becomes 1, that's 5/14. Once we've done the cancellation, 5/14. And finally, exactly 1 blue marble. So what are the outcomes there that work? Exactly 1 blue, not that one, this one does. And 1 blue marble, this one also. So the probability of white followed by blue is 3/8 times 5/7, which is 15/56. That one works. So exactly 1 blue marble. We'll take this and this. They both satisfy this question here. So we take 15/56 and add another 15 over 56 to get 30 over 56, which is 15 over 28, which I think is as simplified as we can get. Okay, so that's tree diagrams. Ready for exercise 8F when I see you next. Okay, cheers.